Hi, welcome back. Now we're going to start talking about objects moving in two dimensions, and the principal motion that we're going to look at is projectile motion. So let's go ahead and get started. Now, two-dimensional motion, it's motion that occurs in both the x and y direction at the same time. Some examples that I have are when you play pool, the ball doesn't just go in a straight line. Well, maybe the line is straight, but if you think of one edge of the table as the x-axis and the other side as the y-axis, then you have the ball moving in both the x direction and in the y direction at the same time. Now, when you throw a ball to a person, it's moving horizontally, and it's also moving vertically. Those two dimensions, the x and y dimension, we have to deal with. We have to do the kinematics equations in the x dimension, and then we have to do the kinematics equations in the y dimension. Now, when we solve these two-dimensional problems, we need to resolve the vectors into components. In other words, we need to break them into their x and y components. Again, that's called resolving the vectors. Then we need to work the problem as two independent one-dimensional problems. They obey different equations of motion. The one constant between the two dimensions is time. Time is the same in both dimensions. Okay, and then once we have our solutions, we can recombine or compose our vectors at the end of the problem. Now, I have a sample problem here for you. We're running in a straight line at a speed of 5 meters per second in a direction that is 40 degrees south of west. And the first question is, how far west have we traveled in 2.5 minutes? And the second question is, how far south have we traveled in 2.5 minutes? So first off, I'm going to sketch this a little. That gives me an idea of what's happening. Okay, so I'm going to draw an XY axis, and it says I'm running in a straight line at a speed of 5 meters per second in a direction that's 40 degrees south of west. So that's the west side and that's the south side. Okay, and I'm going in that direction at 5 meters per second, and this angle is 40 degrees. South of west means that we start at the west side and travel south. Okay, now this is a kinematics question. So west, I'm going to work in the x direction. And so x0 is equal to 0. X is what we're looking for. V0 in the x direction. Well, I need to come up with the x component of the velocity. Okay, so let's see. The west is adjacent to the angle, to this 40-degree angle. So adjacent goes with cosine. So that would be 5, which is the magnitude of the velocity, cosine of the angle, which is 40 degrees. And Vx is the same thing. So I'm just going to write down it equals the initial. The acceleration is equal to 0, and the time is equal to 2.5 minutes, but I'm going to turn that into seconds right off the bat because my speed is in meters per second. So 2 minutes is 120 seconds, and add on to it a half a minute, which is 30 seconds. That gives us 150 seconds. Next up, we need to find an equation that works with this. That will give us distance if we know speed. And the easiest equation to use is x is equal to x0 plus average velocity times time. Well, x0 is 0. And our starting and ending velocities are the same, so our average velocity is equal to the starting velocity. So this would be 5 cosine 40 degrees times the time of 150 seconds. And that would equal about 574.5 meters. So this is the answer for that part of the question. The second part is, how far south have we traveled in 2.5 minutes? Well, I'm going to set up my table of information again. y0 is equal to 0, v0y, which is also equal to vy. They're the same beginning and end. And that's equal to 5. Well, let's see. The south direction is opposite of the angle, and opposite goes along with sine. So 5 sine 40 degrees. We're looking for our final location. Our acceleration in the y direction is equal to 0. And the time that we're traveling for is, again, 2.5 minutes, which we already figured out was 150 seconds. And I'm going to use the same equation, but I'm going to change my x's into y's. So y is equal to y0 plus v. Well, I'm going to notate that y. I didn't notate the upper one as x, but I should have, times t. Okay, so we're looking for y. y0 is 0 again. Average velocity is 5 sine 40 degrees, and the time is 150 seconds. And then after having worked that out on my calculator, I came up with 482.1 meters. So this says that I traveled west 574.5 meters, and then I traveled south 482.1 meters. So these are my west component and my south component. Okay, next up, we have a roller coaster. The roller coaster is rolling down a 20-degree incline with an acceleration of 5 meters per second squared. How far horizontally has the coaster traveled in 10 seconds? And how far vertically has the coaster traveled in 10 seconds? So let's work on this one. I'm going to draw a picture again. So I have a coaster going down a 20-degree incline. I'm going to draw my little coaster up here. Beautiful drawing. I know it's going to be worth money someday, so you better get your copies now. Okay, so now next up, I need to do my table of information again. These are kinematics problems. We need to use our kinematics equations, and to figure out which is the right equation, we have to have our table of information. So in the x direction, we start at 0 meters. And we want to find out how far horizontally we've traveled. So we want to find out what x is equal to. Next, the initial speed. Well, let's see. It doesn't say anything about initial speed, so I'm going to make the assumption that it started from rest at the top of the hill. So the x component of the initial speed or initial velocity is 0 meters per second. And the final velocity, we don't know. And we don't particularly care, because we are looking for how far, which is a distance. The acceleration in the x direction, well, now this is the component, or this is the vector, 5 meters per second squared at an angle of 20 degrees. So this would be 5 meters per second squared cosine, the angle is here, The side adjacent is what we're looking for. That goes along with cosine of 20 degrees, and that would be in meters per second squared. And the time was given as 10 seconds. Okay, what equation am I going to use? I don't know final velocity. I'm looking for position. Sounds like the third equation, which, if you remember, is x equals x0 plus v0 in the x direction, t, plus 1/2 acceleration in the x direction, t squared. Well, x0 is 0. v0 in the x direction is also 0. So this makes our equation a whole lot easier. X is equal to 1/2 times 5 cosine 20 degrees times the time squared, which is 10 squared. And after running that through the calculator, I found out that it traveled 235.0 meters in the x direction. Final part is how far vertically has the coaster traveled. Make my table again. y0, assuming it's starting at the top and it started from 0 meters. I'm looking for the final location, which is y. Why not? Initial velocity in the y direction is equal to, well, 0 again. It started from rest at the top of the hill. I'm making that assumption. The final velocity in the y direction, we don't know and we don't care. The acceleration in the y direction is equal to 5, and the y acceleration is opposite the angle, so that would be sine 5 sine 20 degrees, and the time again was 10 seconds. I'm going to put my units in here. Okay, well, we have the same list of information as we did for part A, so I'm going to assume that I can use the same equation, but I'm going to change the variables over for the y direction. Y equals 1/2 acceleration in the y direction multiplied by the time squared. So 1/2 acceleration is 5 sine 20 degrees times 10 squared, and that's equal to 85.5 meters. Okay, some of you may be going, well, isn't the acceleration supposed to be negative? It's going down. Well, fair enough, but what I've done is I've interpreted this as it wants to know how far vertically, how far horizontally, and I've made the down direction and the left direction on my drawing as positive. We could have drawn this ramp in the other direction. No difference. We would have ended up with the same answers. Would have traveled horizontally 235 meters, and it would have traveled vertically 85.5 meters. Yes, the 85.5 meters would be down because our coaster is rolling down. No problems. I assumed that down was positive. Next up is a problem for you. Both your multiple choice problem and your free response problem. Make your table of information for the x and y axis. That's the way to make this problem solvable for you. It's a lot like the last one that I did. Notice that it passes through the origin with a speed of 6.2 along the y-axis, and it's accelerating in the negative x direction. So figure out your initial conditions and then your final positions. And then you also find out your final velocities for both the x and the y axis. Good luck. We'll see you next time.